When we declare a variable, a set amount of memory is set aside to store the value of that variable. Different data types need different amounts of memory. Characters and booleans take 1 byte, or 8 bits. Integers and floats take 4 bytes, and doubles take 8 bytes. When we set aside memory for a variable, that means we also reserve a memory address for that item. A memory address looks like a hexadecimal number. In C++, you can view a variable's memory address by using the address of operator, which is an ampersand, and you prepend it to the variable's name. Where else have we seen ampersand? When we pass something by reference. Take note of the different ways that we can use the ampersand. When passing by reference, the ampersand goes between the data type and the parameter name. When getting the address of, we use it before the variable name. Every variable has its own memory address. Since we can obtain a variable's memory address, we can also store that memory address in a variable. That's where pointers come in. We may want to create a variable that stores the memory address of a different variable. These variables are called pointers, and they are very important in C++. A pointer variable is denoted with an asterisk, which does not mean multiplication in this scenario. We can assign the value of a pointer variable to the memory address of a different variable of the same base type by using the address of operator. Note that after we declare a pointer of some data type, we don't use that asterisk when we're assigning the data to the pointer. So remember, we declare a pointer with the data type and then the asterisk sign after. And then we assign a pointer to an address by using the ampersand before a variable name. The challenging part about pointers is keeping these operators straight, so make an effort to look over it and they won't cause you too much trouble if you keep them memorized. After we've assigned our pointers to some memory addresses, we can view the memory address that a pointer is pointing to by simply accessing that pointer directly. So, remember, direct access to a pointer gives you the memory address of the variable that it is pointing to. Now, if we want to access the value of the pointed to variable, we need to prepend an asterisk to the pointer variable. In this context, it is called the dereference operator. So remember, prepending an asterisk to a pointer gives you the value of the pointed to variable. We can use this either to get the value of the pointed to variable or to set the value of the pointed to variable. And finally, remember that pointers are variables themselves and also have their own memory addresses. The address of the pointer is the address of the actual pointer variable. So, if we use the address of operator on a pointer variable, we'll get the address of the pointer. If we simply try to output the pointer variable name itself, that will give us the address of the item it is pointing to. Okay, let's review each of these because they're important to keep straight. Number 1. Prepend the address of operator, which is an ampersand, to a variable's name in order to get its memory address. Number 2. Pointer variables are declared by adding an asterisk between the data type and the variable name. Number 3. We can assign a pointer variable the address of another variable by using the address of operator, or the ampersand. Number 4. Direct access to a pointer gives you the memory address of the variable that it is pointing to. Number 5. Prepending an asterisk, or the dereference operator, to a pointer will give you the value of the pointed to variable. And number 6. Also using the dereference operator on a pointer will allow us to set the value of the pointed to variable. So we've used normal variables before. Those are no big deal. Now we want to create some pointer variables. So here they'll be kind of similar to what we've done already, except we'll have an asterisk afterwards. So pointer integer, string pointer string, float pointer float. Now this asterisk, it can be attached to the data type, it can be attached to the variable name, or it can be attached to neither. It's up to you. I tend to prefer the asterisk right after the data type. So, just like these variables are storing some value, these variables also store some value. But their value must be a memory address. We'll use the address of operator to store the address of these variables to these. So for example, I can output the address of number, and I can output the value of number. And if we run this, there's the address of number, and there's the value of number. Now, if I output what pointer integer is currently pointing to, it will give us the same address. Pointer integer is pointing to the address of the number variable. I could also output the address of our pointer integer. And this is a different value, so keep this in mind. The pointer is pointing at a memory address, but the pointer also has its own memory address, because every variable has a memory address. This is number's memory address, this is the pointer's memory address, and this is the address that pointer integer is pointing to. So that can be a little confusing. Just try to keep it straight. For the most part, you're probably not going to need the address of your pointer, so this might not be as important. Okay, so pointer integer is pointing to the address of the variable named number. We can get the value of whatever it's pointing to by using the dereference operator. So if we say output pointer integer, that's just going to give us a memory address. If we actually want to see the value, we have to use the dereference operator. So we run this again, and again we have, this is what's being pointed to, the memory address. This is the value at this memory address. So if you want to get the value, you have to dereference your pointer. We can also set a value this way, and we'll output this again. So we can use the dereference operator to also assign a value at this memory address. Okay. So that's about it for these pointers. You just kind of have to keep everything straight. Normal variables, declaring a pointer. Let's separate these out so we can kind of have these step by step. Assigning a value to a pointer. So, I'm going to erase this. Let's get rid of everything besides string. Let's just focus on string right now. So, we want to assign a value to our string pointer. Pointer string is equal to the address of the text variable. We want to see the value of the variable that's being pointed to variable. So we can say, well, what is the value? Pointer string will output Bob at the moment. Okay, what if we want to see the address of the pointed to variable? Output pointer string, and this is equal to the same thing as the address of text. These two will be the same. See the value of the pointed to variable? We can also change it. Change value of pointed to variable. Say pointer string is now equal to Jim, and we can output it again. So this might not tell us much, there's not very good labels, but we can say address of text. Both of these will give us the same value. Value of text. This will give us the same value as just outputting text. We can change this either that way or this way. And again, we can output them again the same way. Okay, so that's a basic high-level view of pointers. We haven't gone into why you would apply pointers yet, but it's good to just kind of break them down and look at them step by step and keep them in mind, because once we start applying these, it'll be harder to kind of investigate everything individually. We can use pointers to create new variables as well. This will come in handy once we're working with dynamic arrays and building our own data structures. The new keyword allows us to allocate memory, and the delete keyword allows us to free that memory. Therefore, anytime you call new, you should also call delete. Here's some sample code where we create a new integer. When you create a new variable in this manner, you still need to follow the rules of pointers. You can only access the variable's value by using the dereference operator. Warning, if you neglect to delete to a corresponding new, you will create a memory leak. Each time your program is run, it will allocate the memory, but it will never free it. To regain the lost memory, you would have to restart your computer. Secondly, after you free the memory that a pointer is pointing to, it is also good practice to reassign the pointer to the value of null. Otherwise, it will still be pointing at a memory address, and it could cause an access error, because that memory address could be reused by another program after it has been freed by your program. Up until now, we've passed variables by reference in order to return multiple values from a function or to optimize our program by avoiding copying of objects. We can do the same with pointers by passing memory addresses. When you utilize pointers in this way, there are more steps to remember than with simply passing variables by reference. First, make sure your parameters are pointers. Second, make sure to dereference the pointer parameter when you're assigning values to them. And third, make sure to pass in the address of the variables in question using the address of operator. For the most part, it is simpler to stick to passing parameters as reference if you can. We can also return a pointer from a function. We just need to make sure to set the return type to a pointer. Also, we'll store the result of the function in a pointer variable as well. We can also use pointers to point to variables that are types of objects, classes or structs. Our objects may have member functions and/or variables, so if we need to use the dereference operator on a normal variable to get its value, how do we dereference an object to get to its members? We can use the dereference operator in order to access members of an object. However, note that you will have to surround the dereference operator and the pointer name with parentheses. The following will not work due to C++'s order of operations. You can also use the member access operator as a shortcut, instead of wrapping the dereference operator and that pointer name in parentheses. You can use this with both member functions and member variables. Also, it is more standard to see this arrow operator used when using class pointers. So when using a pointer to a class object, remember that there are two different ways to access the members. We have a lot more to cover with pointers, and this is just the beginning. Next up is memory management and creating dynamically sized arrays, and later on we'll be writing data structures that contain pointers and manipulate memory. So, as always, make sure to practice. Let's say that we're creating an array of students. So students, we have 10. Now we could iterate through everything and just modify each student with the subscript operator. So let's say we're going to input the name, enter a name, input student name, enter the grade, and we'll input the grade. But we have another way we can do this. We can create a pointer, so current student. Now, it's hard to really get into really great reasons to use pointers before we get into data structures, but bear with me for a moment. We can say pointer current is equal to the address of the student at this index, and then instead of dealing with each index like that, we can say pointer current and then use the member accessor operator, which is the arrow, and store it this way. So this might not make a whole lot of sense why you wouldn't just use the subscript operator, but in the future it could be really useful to point to specific objects. We're just doing this as an example. So say you go through and set all the students, then we want to display all the students. We can say cout name, cout grade, and this will work fine. Enter name. Now I have to think of 10 names. Let's change this maybe to, I'll have const int student count. We'll make it 2. We'll run that, and also this should be that. Okay. We'll run. We'll have Tesla and Magellan. And I did not put new lines, so it's hard to read. Enter name. Oh, also, I entered a string instead of a grade, so that's the problem. Okay. Tesla, grade 5, Magellan, grade 6, and there you go. So, in this case, not a great reason to use pointers, but it's an example of how you can use a pointer. Here's another example of how we can use pointers. So I've pre-made a class called room. It basically just has a name and description, but then it also has pointers telling us what is to the north, south, east, and west. Now, when we initialize our pointers, it's good to have them set to null. That way we can see if it's not null, we assume there's something there. If it is null, we ignore it. And then there's just a simple function to set up the name and description. There's a function down here to set up the rooms. So I've set up a few different descriptions, and then we can set where they are in relation to each other. So rooms 0 dot, we can set what's to the north. It's a pointer, so we'll set it to the address of rooms number 1. And let's say within rooms 1, which is a cottage, let's say to the west is the closet, so rooms 2. Now, if we're going to have these pointing that way, we should have them go the reverse direction as well. So dot south would be room 0, and rooms 2 dot east is equal to rooms 1 address. So there we go. We have these pointing to each other, and that's pretty simple. Back in main, we've declared an array of rooms. We've called the setup function, and I've made a pointer that points to whatever the current room is. So I've just arbitrarily set it to 0. So every time through the loop, we'll output the name of the room and the description of the room. We don't need to know the current index. All we have to do is just use the pointer and use the member accessor operator. We'll get whether the user wants to move north, east, south, or west, and then we can handle the movement. So, if the user wants to move to the north, we need to check, is there anything to the north? So, for our current room, we can check north. Is it equal to null? Well, if it's not equal to null, then we can move in that direction. Now, I'm going to move this into here just because that makes it a little bit more concise. And we'll do the same here. So if they want to move south and there is a room to the south, it's not null, we'll move them to the south. Now all we have to do to update which room we're in is say pointer current is equal to the address. Well, no, I don't think we even have to do that. We'll just set it to north. So this is storing the address of the room to the north. Whenever we want to move north, we simply update the room we're pointing to. So we don't have to worry about indices and all that. We are storing the rooms in an array, but as far as after storing them in the array, we don't even have to worry about it anymore. We just have a pointer to whichever room we're currently in. We check to make sure that an adjacent room exists, and then we change the pointer to that address. So for example, let's also just output room address for the sake of it. And remember, pointer, the value of the pointer is the address of some room. So let's go ahead and run this. You're in a dark forest. Now it's not telling us which directions we can go because we haven't programmed that in, but let's just quickly say if to the north is not null, we'll say you can go, well, let's start out by saying you can go, and we'll append to the end. North. And let's add a tab, just because. So, you can go north. I'm going to make this all in one line, just to make it a little bit easier to read. Else, south. You can go south. East, west, east, west. So, we don't need these to be else-ifs, actually. We're going to check each of these separately. You can go north. Also, we probably need an inline right there. There we go. I can go north. Let's go north. Now we're in the cottage. We can go south or west. West. Now we're in the coat closet. So we can just go between each of these. We've made it pretty simple to implement some sort of map system for a text-based game. What else could we do? We could do an inventory. We could do monsters or other players. There's a lot of stuff we can do with this, and pointers makes it a lot easier than dealing with an array.